probably give Michael a hand for organizing this and bringing us all together from literally around the world. So if you're looking at the home. So as I'll share with you, my career has been in the propulsion, pushing end, and so it's been a real treat for me the last couple of days to understand more in depth of what the payload community is all about. So as I'll get into my charts, my office is responsible for a portion of the SLS rocket, and more specifically, we manufacture the adapter at Marshall Space Flight Center that will house the 6U CubeSats that will launch on EM1. But then at the back of my presentation, as it was stated earlier, we're full for EM1. I'll show you what the opportunities are for EM2, where we have a larger volume to take advantage of, since we have a larger upper stage that we'll be using to increase the performance of the vehicle. Okay, so here we are. Just put it in context. It's a big rocket. Okay, and before you think it's just yank showing off again, it's big because it needs to be. Okay, so the primary mission here is to launch the crew capsule, and that weighs about, well, it weighs over 30,000 pounds. Okay, so I like to say if I try and jump, I'm going to jump this high, and we all know about the gravity well. Well, if you're going to launch something like that, it takes a lot of power. So we've got 4 RS-25s. That's the engines that were on the back of the orbiter during the space shuttle program. There were 16 of those available to us after the program was retired. When they were built, they were worth about $70 million a piece, so we were glad to have them. Use those, and so we have the core stage that is analogous to the external tank. That's our gas tank. And then we have the solid rocket motors. They're a stretched 5-segment version of the 4-segment model, if you will, that was flown on the space shuttle. I was the lead. I worked the RSRAM for about 20 years, and I was the lead for extending that out to 5 segments. Took the performance of that motor from 2.9 million pounds of thrust to 3.5 million pounds of thrust. But that's a large scale. It's relatively easy. The hard stuff is tenth of a Newton kind of things that you guys work on. So big horsepower is not that hard, in my opinion. It's the small stuff to do what you have to do in orbit. It's the challenge. So what my office is responsible for is from right there to about right there. And so what we have here is the launch vehicle stage adapter, and that's the adapter that comes off the core stage, the gas tank, and then that attaches to the hydrogen tank of the upper stage that we purchased from the United Launch Alliance over in Decatur, Alabama. That's the same upper stage that is used for the Delta IV launch vehicle. Okay, so what we have here is a 70 metric ton configuration, and that was that configuration was developed to get us quickest to the launch pad. Okay, and one of those ways to do it is we had existing solid rocket motors, but also an upper stage that we could take advantage of. So where we get the opportunities for EM2 is when we go to a larger upper stage, where this has 1 RL-10 engine, the exploration upper stage will have 4 RL-10 engines. It requires a bigger volume, and that's where we provide the opportunities for the CubeSat community. So, and then here is, in this adapter here, there's a smaller adapter that I didn't mention. It's roughly this high. It's angled like this, and it has a isogrid lattice structure machined to the inside. So we have the intersection, we can tap those points, and that's where we can attach these brackets. Okay, so you see here represented tie back deployers inside the volume. And then we also have, so we have 13 of these for EM1. Then we have an avionics box that we manufacture from our Space Flight Center as well. It's kind of a glorified daytime. But once the Orion capsule is safely on its way, then it will send the signal to deploy each of the satellites. And I've got a chart that shows that. Okay, so here's the bus stop. So we launch, we come out, we get past the first Van Allen bell, and then because we can't deploy before then because we still have the Orion capsule attached to us. All right, so they go off and go on their way, and then 30 minutes, I guess they get off about right here. 30 minutes after that, where we don't have the risk of recontact, then we can start thinking about deploying the satellites. So the first bus stop is where we have the first opportunities. You can see the subsequent ones. We deploy the CubeSats, and then we require they wait 15 seconds before they power up or balloon their solar wings or anything like that, so they can safely clear the adapter, and then they can power up and go and do their thing. So these are the bus stops through the mission, and I did mention that after the crew capsule is gone, the ICPS, I think this was also mentioned yesterday, re-vectors and goes, it wants the position to go into a heliocentric disposal orbit. And then that's the opportunity when we can start releasing the CubeSats. So this is primarily based on the primary payload, be it crew or cargo or home manifesting payload we have, but there is some adaptability here. Now, one nice thing too is, not Thomas Harding, although I think he's from London, you know, we're far from the madding crowd here, right? So we get out past the Van Allen belt, we get you out into deep space, give you the opportunity to gather some science around the moon. So here's the schematic that shows after the Orion's deployed on its way, and how it goes into its, we call it the barbecue goal, and then it starts deploying the CubeSats. And then right here, that's a composite diagram in there that isolated body damage, so we don't build up hazardous gases. I didn't do this video, by the way. I've got people. Okay, so EM1, this is the manifest that we have. You can see a broad spectrum of locations and international partnerships, university partnerships, international partners, and then of course, as we mentioned throughout the 2 days, the Centennial Challenges that we'll have the announcement next week for who fills in those final slots on the manifest for EM1. Okay, so I was talking to the folks back in March, we're getting ready for this. David Hitt was back here, who was here last year talking to you folks, and we were reflecting that there's a difference in the interest when you say you're designing a rocket or thinking about a rocket versus when you got a real rocket. The interest goes up on the stuff function. So this is to show you that we've got a real rocket at this point. You can see the 4-stage production with its length. I'm assuming that's the hydrogen tank. There's the upper stage that we purchased from United Launch Alliance, and as you can see, that's at Cape Canaveral. That's been manufactured and shipped to the Cape. It's over on the Cape side, the airport side, if you will, where Delta has a checkout center. It's getting checked out, and then in the August timeframe is when we'll send that over to the Cape. It wasn't due by agreement till January, so we have to actually pay for it. So the hardware's showing up now at the Cape. This is the launch vehicle stage adapter that I was referring to. It comes off the 4 stage. It's about 28 feet in diameter at the bottom, about 28 feet tall. This is going into a structural test where we took this adapter, the MSA adapter, and a flight article like this, and we did a load test. All right, so we integrated all 3 pieces and took it up to 1.4 times the expected loads during flight, so that we can anchor our models and make sure that we can stand up at flight readiness review and justify our defendant for safe to fly. So that's that being, it'll be lifted and lowered into that standard. It was, that test completed about 2 weeks ago. The solid rocket motor that I was part of, you can see that firing there. We've completed qualification testing out in Utah. And with its length, the 4 segment, we didn't need these right here, but with the length, it sags so much in the middle because you've got over 1.5 million pounds of propellant in there. It sags several inches, and it actually, at the field joint there, will bend the pins and deform the hole. So we had to put these midspan supports there to hold it until it fires and burns out the propellant. As it fires, it gradually lifts up. So that's done. The main engines, the RS-25s, have gone through testing down at Stennis. They've upgraded the engine controller for the engine, so it's just a little bit more powerful than what we flew during the show. So we've tested them individually, and then coming up here soon, they're finishing the completion of the test stand so they can fire 4 RS-25s at the same time. the static configuration. So that's going to be a pretty exciting test. So that's everything associated with EM1. And then Block 1B work has already started as well. They started EM2 production for some of the core space hardware down in the chute, but this is the adapter that will go for the exploration upper stage. So I'm not sure which tank this is for, but the point being that although we're getting close, hopefully, to the launch for EM1, although, as has been mentioned, we've run into some challenges, and that launch date is being redefined for some time in 2019. Work is proceeding towards that end. Okay, so Block 1B. The key is we take that up to 105 metric tons, and it's because we have a bigger adapter there. So let's get to that. So Block 1, we had 13 CubeSats. Block 2, we have this payload adapter with varying diameters for the ring, depending whether you're a stiffness defined payload or a real heavy payload like the rover lander, which weighs about 16.5 tons. We can change the height of this adapter, but we have these quadrants that we can put the CubeSats in. And the other key point here is that in the next slide I'll show it, we can go in size from 6 U's on up to 27 U's and even ESPA-class type payload configuration. So we could put, I think, 20, 21, 6 U's in here for a mixture of I think right now we have 10 6U CubeSats, a couple of 12 U's, and then a couple of 27 U's. So point being, this is adaptable based on the interest and the manifest that we define for EM2. And these are the sizes that we can, I just described, we can change. And to me, that's not football, but I assume that's what it is to do. And then the summary is, again, it's a real rocket. Although admittedly we're going to have some challenges getting to the launch pad, we're going to get there. And so we're going to launch that first configuration and deploy the 13 CubeSats for that payload. But I think there's a real significant opportunity for the community in the EM2 Block 1B configuration where we can house even more of those. And what I described in the last page was just on the payload adapter. We still have the lattice work structures that we're considering maybe putting brackets on there as well that we can house more CubeSat payloads. But that's forward analysis wise. So if there was one takeaway from this chart is there's more room coming. So be thinking about how you might manifest a ride on EM2. And then as you're doing that, if you need to know what the environments are that you're going to be subjected to and what you might have to certify your hardware to, we've just completed the mission planner's guide for SLS that will give you the loads and environments that you have to develop your spacecraft to. It's publicly available information. But even though it is publicly available, we're having a hard time getting the public affairs folks to post it on the public NASA website for now. So for now, you can send an email to this address and we can send you an electronic copy of that payload. I still got a minute. So any questions?
Okay, I can first.
I was wondering if you were considering putting in a sort of kind of CubeSat mothership kind of addition in there as opposed to just launching them from the inside of the fairing.
Not that I'm aware of at this time, but I'm sure that probably somebody, well, what used to be the flight projects director, they're probably considering things of that nature. Our office right now is not thinking of that, but that's something certainly I can take back and ask if somebody's thinking about that.
That sounds very interesting, this project. Public for you means public for the US only, or also for European or global people? Global.
Yes. Yeah. Now, when we work with the international partners, that has to work through headquarters in the State Department to work those agreements and reimbursables and that sort of stuff. But no, as you can see on EM1, we have international partners, JAXA, ESA.
Yeah, we listened yesterday was only for US citizens only. Project.
Yeah, I don't recall that conversation, but no, this is what.
Okay.
That was the CubeSat challenge.
Oh, yeah, exactly. Yeah, that was just for that specific challenge, and I think that's because of rules giving money to foreign
I think it was
nationals.
for the money.
Yeah, it's only because of the money, not because of the technology.
So I was just curious of the deployment mechanism from the inside of the fairing, if you will. Are you instigating a minimum deployment velocity for these CubeSats to clear the fairing? Or is that
So there is, and I don't recall what that is on the top of my head. It's a tie-back dispenser. It's commercially available dispenser we procure through the launch services program at NASA. And so it has, whatever it's rated. But
yeah, it's
deployment load is, but I just don't call it all.
Okay, cool.
So I'll ask the commercial question, how much for a 6U CubeSat for ride on EM2,
Well, I assume it'd be the same as EM1.
which is not a number I'm aware of.
Yeah, it's not a cost to you. So other than the cost you have to incur to get through the payload review, system safety, reliability, panel reviews, and all the work to meet the NASA requirements, but in and of itself, charge to launch them.
Take some time.
Give it a this.
Two questions, actually. You talked, okay, fine. You talked about U12. I'm not aware,
12U.
12U, sorry. I'm not aware of a currently available dispenser for that, and I think you showed it as 2x2x3, but do you have a plan on the dispenser for the larger U types of CubeSats you're talking about?
I don't currently here today. I mean, I know that's in the work, but I can't describe that for you.
And second question, what about the launch for the Europa Clipper?
That's on the books. They plan to ride on SLS.
And
So that would be SM1 is the launch that would be on. So that'd be following EM2.
and it also would have CubeSats.
Yes, we plan on this being a standard capability of the launch vehicle going forward. If we've got the volume, we might as well take advantage of it because we can provide again that access to deep space that the community is certainly interested in.
Do you have plans for going beyond 3 CubeSats in one dimension anyway? Your largest dimension here is 3 cubes.
I think if the community, and I'm kind of talking out of turn, I would probably turn it over to Anthony for that sort of discussion. But I would think if there's a significant interest in the community, we'd figure out a way to make it happen.
Sorry, Jerry, we'll touch you.
Yeah, that's all right.
So I saw that on the second one we have the SLS-class. That's 1 meter roughly by 0.7 by 0.6 meters. And 180 kilos is what we usually call an SLS-class spacecraft. So that's a lot bigger than 3.
Well, what about a 1 by 1 by 6 6U?
I don't know. That's the volume constraint I don't know about.
Yeah, and really I don't have all those answers for you.
And I'd say, actually, I'm just trying to get something on the slide. If you look at the diagrams, expensive in the United States, there's mentions 2 categories because
Anyway, Jerry.
Just a quick one. The safety requirements, are they going to be the same like for ISS, or do you expect any higher requirements on the safety?
I would say right now they're probably more stringent than ISS, and certainly the system safety reliability technology we offer has been quite rigorous. We've made some changes in that to make that more efficient in working with the community. I think that's our biggest challenge, to be honest, is to learn how to work efficiently and change our mindset as it exists today to work with this community. So yes, we've made changes in that review process for sure. And going forward, we're continuing to discuss how we can be a viable option for this community because we're not the only option for you guys. In many cases, you can go somewhere else. So if we make it hard or too difficult, expensive for you to work with our process, then you're just gonna pick somebody else to ride on, right? So, yes, that is certainly something we know we need to work on, and we are working on it right now.
I'm not sure if I missed it. Did you say there are opportunities for like 100 to 300 or 500 kilogram class vehicles?
Well, up to the ESPA-class is what I said, whatever the payload capability that can reside on the ESPA. Now, we have co-manifested capability on Block 1B, which may be thinking of. So as long, we got the primary mission that's going, we can co-manifest fairly sizable payloads there in lots of kilos kind of weight class.
Great. Cool. Is that one last one up there? I think we'll close it there.
So can you elaborate on the EM tool? How is the allocation of slots going to happen? So you say they will be public, but how are you planning to do that?
I didn't catch all the questions. The payload users guide, mission planners guide, is that what you're referring to?
So for EM tool,
Yes.
you said that the slots will be publicly available. How is the allocation going to happen? Is NASA going to choose through a contest, or you're going to?
I think it's going to be a mixture. To be honest, right now we're so focused on getting through and learning how to process the 6 CubeSats for EM1. That's taking up most of our bandwidth. And so that's where we're working to find how we're going to do that. And a lot of that's how the headquarters team is going to work with Jay Jenkins up there to find how that's going to play out. So that's, although there's a plan, I think it's going to be modified, but right now we're kind of focused on getting through EM1. But the main point would be to look at that mission planner's guide and know what that means to fly on that more powerful configuration that we follow on to what we fly in 2019.
Okay, well with that, thank you very much, Andy.